Hello, everyone. I'm really excited to see you all. I'm just a little bit nervous, so I'm sorry for that, but I hope it will get better as we start diving into language features where I feel myself more comfortable. So my name is Michail Zarečenskij. I'm in charge of language design in Kotlin, and today we are going to take a look at language features in 2.0 and beyond. We'll begin with a brief recap of past changes in Kotlin and the reasons for the K2 compiler. Then I'll highlight the main changes in 2.0, and we'll be looking at all the new exciting features we'll be able to ship after 2.0. And I would like to start with a short overview of Kotlin and its history, as it's hard to talk about the present and future without mentioning the past. So the first thing that I'd like to mention is that the first version of Kotlin was released about 8 years ago, and a lot of things has changed since then. Considering language features alone, it's worth mentioning that coroutines, functional interfaces, multi-platform projects, type aliases, and many others appeared after 1.0. And it might seem like these features have been with Kotlin since day one. They were actually introduced gradually. And a closer look at the changes reveals features like trading commas, range until operator, and exhaustive when statements. And if we look even closer, we can see that over the past 8 years, the Kotlin programming language has evolved pretty significantly. And Kotlin updates has resulted in the addition of several dozen language features, not mentioning bug fix for smartcasts and type inference. So if we consider these features, can we say that Kotlin is mostly about a language? Well, we definitely can say that Kotlin is a language, but of course it's not only. Apart from the core language, Kotlin targets several compilation environments, including JVM, native, and web. We also offer Kotlin scripting with its shiny new Gradle Kotlin DSL. Kotlin is extensively used for Android and server-side development and has all the necessary technological stack to develop, debug, and publish applications. We develop plugins for IntelliJ IDEA and Fleet. We provide a range of our own libraries, such as coroutines realization, and has thousands of open source libraries from our community. And furthermore, Kotlin offers somewhat unique capabilities for extensions via compiler plugins, allowing for the adoption of new styles and frameworks. And of course, I can get around with the Compose compiler plugin that enables Jetpack Compose, a toolkit for building UI declaratively. And here's the new Kotlin compiler. And a very reasonable question is, why do we need this compiler if we could achieve all of that without it? The first thing is that some of Kotlin language features and directions have appeared quite unexpectedly. So the compiler wasn't ready for specific requirements. In general, that's okay, as we can't predict the future, and we don't know which language features will be needed in, say, 5 or 10 years. But some language features require a slightly different compiler architecture. And specifically, our multi-platform capabilities require non-trivial contracts from the compiler to unify all the work across multiple targets while managing both common code and platform-specific. Now that we have vision for multi-platform projects, we want to double down on each direction and need a solid foundation in our core compiler. The next issue concerns our interaction with compiler plugins and IDEs. You see that originally the compiler was developed in the same repository as the plugin for IntelliJ IDEA, so resulting in tight integration with our IDE and utilizing all the necessary internals of the compiler. And this allowed us for rapid development, but came with its own cost. So now with more and more tooling around, it became extremely hard to maintain those changes without breaking changes. And once again, providing opportunities to write compiler extensions for JVM is one thing, but offering support for multi-platform plugins is a whole different story. And of course, there's compilation time performance. You can never be truly satisfied with performance, especially with the growing lines of code to compile and with extensions for Kotlin. And here's Kotlin 2.0, with all the ideas and foundations in mind. So Kotlin 2.0 has just released, and the update includes more than 80 features across different subsystems, including build tools, incremental compilation, and so on. And one of the most significant aspects of Kotlin 2.0 is its focus on performance and correctness. However, as it usually happens when you're writing something, you end up with a bunch of features. So we actually have more than 100 features in this release. But as you see, none of them are syntactical. So how can we describe these changes in the terms of the compiler? One of the key changes in Kotlin 2.0 is the introduction of the front-end intermediate representation, or FIR. So it's a transformative change that deconstructs complex language constructs into simpler, more manageable ones. And so this so-called desugaring now happens way earlier than before, allowing us to have more consistent rules for analysis. We also introduced a phased approach to analysis process. And with this approach, it's possible to provide specific points for integrating additional functionality into the compiler and IDE. Moreover, the compiler will be aware of such changes. And a key benefit here is that if you develop a compiler plugin, you don't need to provide a separate IDE plugin anymore. With the current architecture, our IDE will automatically recognize new compiler extensions and will properly highlight new constructions. And we introduced a new control flow engine from scratch, designed to offer more sophisticated analysis of the code's execution path. So with this engine, the compiler can better predict and detect unreachable code, potential bugs, and other issues. And this is also where most of our new features come from. But what are user-visible changes? So I'm going to highlight just a few of them. So let's start one by one. Front-end intermediate representation. One of the good things of Kotlin, and indeed any powerful language, is their ability to compose different language constructs. And Kotlin, for example, has many operators designed to work together, although the compiler implementation might not always align with your expectations. And to give you some intuition, let's start with this code. We have a simple function that increments the first element of the mutable list of longs by adding an integer literal 1. Note that we used a numeric conversion from an integer literal to a long. But now let's simplify this by using plus assign. If you do this, the compiler will emit an error because it failed to combine operator calls and numeric conversions. And we could meet such issues from time to time here and there. And here's where our intermediate representation shines, as the compiler can now desugar this code and then perform all the necessary conversions. And note that how in such a simple case, we've used actually 3 operators and a numeric conversion altogether. And the cases can be even more complicated. For example, here we have the class box that holds our mutable list of longs. And in the function, we want to increment the first element of the list again. The compiler fails to do so, even if we provide specifically that we want to increment it by long. And here, it's a slightly different reason, which is related to using a nullable left-hand side of a plus assign operator. And again, in 2.0, such expressions can be properly desugared and adding even more operators to the desugaring process. So again, Kotlin's power actually comes from its composability. And with Kotlin 2.0, we have more consistent and robust rules for operators, delegate properties, and extension functions. And of course, their combinations. But let's get back to features. The next big thing is our new control flow engine that helps us to predict code behavior. Or in terms of Kotlin, it means that we'll get more smart casts. Let's see a few particular examples. This is a very common code. We have the class cat with a single method, and in the function petAnimal, we check if our object is a cat, then we can safely invoke its method. Pretty straightforward. And one missing piece here is that if we extract the nullability check to a variable, we'll get an error that we can't call the method anymore. And the reason is that our variables don't contribute to the smart cast logic. only a few expressions did, like type checks or null checks. And with the K2, local variables can also contribute to SmartCast and carry necessary data flow information. So in the example above, our code will compile fine. And speaking about composability, the feature works with all regular SmartCasts, including contracts. And in the example, we have a class card with a property holder of a nullable string type. And our variable card with holder can produce two SmartCasts. The first one is from the type check, and the second one is from the function is null or empty. And they both will be applied in appropriate blocks of code, resulting in SmartCasts. The next change is about SmartCasts inside change enclosures in lambdas. In Kotlin function, this Kotlin code returns the index of the maximum value in an int array. And here we are interested in this part where performing a SmartCast. You see, this check didn't produce any SmartCast for the max I variable, because the variable is captured inside the lambda. And in general, we don't know anything about this lambda. It can be invoked or stored somewhere or be executed even after this function, and which could affect the SmartCast behavior. But we know that for each indexed function is an inline function, so its lambda has to be executed in place right here and cannot be stored anywhere. So starting from 2.0, the compiler treats all inline functions as having an implicit call-in-place contract, explicitly telling the compiler that such lambdas cannot be stored anywhere. And this allows for more SmartCasts, including SmartCasts inside change enclosures. The next somewhat minor update, but important, is about SmartCasts after a logical operator OR. So let's have this simple interface status that has a function signal. And three sub-interfaces, OK, postponed, and declined. Previously, the compiler didn't perform any SmartCasts after a logical operator OR at all. So if you check that our variable is either postponed or declined, we still couldn't invoke the function signal. And with the K2 compiler, we started to merge information from the OR operator. And now we can infer that our variable is the closest supertype of postponed or declined types, which is status. So therefore, we can invoke the function signal. And there are more just bug fixes and such features in the release. But I'm not going to stop here, so let's proceed to the features that will be able to ship after 2.0. So we have a lot of stuff on our plate. So regarding multi-platform with Swift exports, stable KLib formats, with tooling like Ampere, Gradle project isolation notebooks, with more libraries, compiler improvements, and of course, language. And we've seen quite a few changes regarding to SmartCasts and data flow framework in general. So why do we focus on this topic at all? We see that describing control flow is one of the main tasks of a developer. And nowadays we are working with data more and more. So we'd like to provide a more concise syntax to inspect data and describe conditions. So we see that this actually improves readability of the code, and in many cases, it removes layers of nesting. So for example, Java includes switch expressions and pattern matching on records, although Kotlin has included some of those features, like when expressions, and is actually at the forefront in many others with the notion of SmartCasts. We should keep improving to give our users even more powerful tools to express the control flow. And you see that SmartCasts actually one of the best way to do this. A SmartCast reduce cognitive load because you don't have to learn any new constructs in the language, and this mechanism can be extended gradually over the Kotlin releases. And here's our first direction, where we are going to provide more and more updates regarding data recognition and deconstruction. So this area includes such features as guards, context-sensitive resolution, data class improvements, generalized ADTs, and effects system capabilities. So let's dive into these features one by one. We'll be using this code over the few examples, so let me explain it a bit. Here we define a composable function designed for use in UI, but it actually doesn't really matter. It takes a sequence of data and ID string as parameters, and within a lazy column, it finds the last data object matching the given ID. Then, based on the type of the selected source panel, it conditionally displays the different UI elements. And if the panel is a news panel and not blocked, it displays news result with the found data. And again, here, as in the keynote, we actually repeated the variable search panel 4 times. And usually, such repetition in your code means that this variable is central to deciding which component to render, or which code is actually important to decide about the logic. And however, repeating the variable multiple times could potentially make the code less concise and slightly too harder in the future, as the variable search panel here was intended to use only in the when statement. And in Kotlin, we know that we can leverage so-called when with subject construction, where the subject search panel in our case is captured and restricted to the body of this when. And yes, if we do this, we get a compilation error that end is forbidden at this position. And the reason is that the when expression in Kotlin allows for type checking or matching against specific values only. And to mitigate this aspect, we are going to introduce guarded conditions in when. And we are going to introduce them in Kotlin 2.1 in beta version. But can we do better? Actually, you see, we still have to repeat search panel for each branch, which makes the code more variables than necessary. And we still have to parse through redundant information. So the next little improvement will allow handling through instances of sealed types or enum entries directly, without repeating the base class name when the expected type is well known. So this approach reduces the need to repeat search panel, making the code cleaner and more focused on the unique handling of each panel type. And the feature is also applicable to all the places where the expected type is well known. And one of such places is the addition of default values to parameters. So here we again repeat the status a few times, and I think that's enough. So with context-sensitive resolution feature, it will be possible to emit status on the right-hand side. And we are going to release this feature in 2.2 as experimental. JDT style smartcasts. Here I'd like to start with a short terminology problem, because JDT stands for generalized algebraic data types, and we don't use this term. So this term comes from functional programming language and type theory, and we don't usually refer to this term in Kotlin. Instead, we are using field types and data classes instead of sum types or product types that are used when people are talking about algebraic data types. But I'm still going to use this term because, well, it's well known and we might change it in future. But keep in mind that we actually don't have this term in Kotlin. We are not that functional. So here the Kotlin code defines a field class container, which holds a value of a generic type T. Also, we have int container, which is a subclass and contains an int value, initialized to 42, and string container, which is a subclass and contains a string value, initialized to Kotlin. And we have a simple function box that just takes a parameter of a generic container value and returns its value. Again, pretty straightforward. But if we do the same operation for subclasses, we'll get a compilation error, which might be surprising at the first sight. And if we take a closer look at the problem, we can see that we promised to return a value of type A, but we are actually returning either string or int, which is forbidden by the compiler. And if I inline those values, it will be even more clear that this code is actually non-trivial for the type system. But we definitely know that at runtime, this is perfectly fine, as there can be no any values of different types. And this is what we call a JDT style smartcast, which means that we use subclassing information to convince our compiler that this generic A can be either int or string after these type checks. And this topic is under research, but we see pretty good results, and we are going to publish a detailed kip with a proposal quite soon. Named-based destructuring. So data classes in Kotlin are very popular, but we made a few mistakes them, as I think. And one of them is that it's possible to destructure your data class with arbitrary property names. And for example, here we have a simple data class user with name and last name, and I can provide any names to when I want to destructure such a class. For example, surname and first name, which can lead, of course, to further mistakes. So at some point after Kotlin 2.0, we are going to provide gradual warnings and then errors in the end, so that it won't be possible to use arbitrary names to destructuring your data class. And ultimately, we like to avoid component functions for named-based destructurings at all. So there will be less auto-generated functions in data classes at some point. And also, we are going to provide special syntax to assign new names to destruction properties. So the code in general will be more safe in future with using data classes. So to repeat, we've just checked a few features like guards or our pattern matching without notion of binding, context-sensitive resolution, generalized ADTs, data class improvements, and we also have this part for effect system capabilities, which I'm not going to cover today, as it's I need a few hours to cover this topic, but we are going to improve this part with each release of Kotlin. But let's get back to our original example. We still have a couple of interesting functions, and one of them is lazy column function. So the lazy column function is a composable function provided by the Compose UI toolkit. And it's used to display a list of items that are lazily loaded. And as many UI dedicated functions, it has a lot of parameters that carry rendering information. And such functions heavily utilize the use of parameters with default values to avoid a lot of overloads that is required to cover all the use cases. But what if we decide to add a new parameter to such a function? In this case, we'll have to add it to a new overload to maintain backward compatibility. And these are just a few examples where authors had to add new overloads already and deprecate previous versions of function. And the addition of a new overload also means that we have to duplicate all the documentation for all the parameters, which, as we saw, is a lot. But if we take a closer look at our function, we can notice that many parameters are just settings that are shared between similar UI components. So we propose a solution that follows the idea of having a class to represent the arguments. And with this proposal, provides a way to design APIs with a growing number of optional parameters, keeping source compatibility and also aiming at keeping binary compatibility as well. And we want to leave the door open for library authors to have full control over the representation of the arguments by skipping explicit creation of such classes at call sites. And it was one of the features dedicated to the area of library code evolution. In this area, we are also working on signature management features, aiming at providing mechanisms to enforce named parameters or check return values, which becomes more and more important when you are managing resources in Kotlin. And of course, we have a lot of data regarding kdoc, so we are going to provide improvements here as well. But we still have one interesting function in our example, and it's the function last from the Kotlin standard library. The function iterates over each element in the sequence, and for each element, it checks if the element matches the predicate, it updates the variable result to that element. This means only the last matching element will be stored in the result by the end iteration. Right. But what if the predicate checks for nulls? You see, our collection can store nulls, and we can differentiate the situation when we didn't find from the situation when we found null. And to handle this case, we need an additional example, an additional variable found that will be updated if we actually found the required element. And this solution comes with the price of more complicated code and an unchecked cast at the end. And in order to get rid of this additional Boolean variable, we could use some private object as a tag that will serve us as a signal that we didn't find anything in the sequence. But is this approach good enough? Well, we are definitely not happy with it. And because in this case, we have to convince our type system by using the most generic type any. And we still have this unchecked cast at the end. So this code clearly shows that something is missing in our type system. And the missing part is the ability to specify union types for errors and exceptions. So the code uses a union type for the result type, and union types allow a variable to hold a value of one type or another. And in this case, either an element of the sequence or a special not found object. And note that in this case, the type system immediately helps us to streamline the code by putting automatic smart casts where it's needed. And I have to mention explicitly that this pattern with unions is designed specifically to handle errors and distinguish between successful and error cases. So we are not going to add union types in their standard form to the language, as you'll see in the talk by Ross Tate, who is working with us. Union types has one nasty problem, namely they're undecidable for type checker, and we don't want to provide such mechanism in our language. So no union types in general, only for errors. And we see how they could be also extended in other type positions, and we can provide special operators to work with errors. The next area is about increasing abstraction in Kotlin. And here we have a few large features which are probably one of the most exciting in Kotlin, such as context parameters, which are going to be released in beta in Kotlin 2.2, explicit backend fields, union types for errors, string literals and string templates. So with preliminary changes in 2.1 as for multi-dollar interpolation, which was resulted actually in our more ongoing work on string templates in general. And of course, deep immutability, which we find really important with the upcoming value classes on the JVM. And here I'd like to mention the explicit backend fields. So here we have this pattern with my view model, where I have to repeat city 3 times in this short example. And you actually see this pattern has appeared in more than 100,000 files on GitHub. And that's definitely a signal to introduce some language feature regarding this pattern. And usually it's a combination of list to mutable list, shared flow to mutable shared flow, or live data to mutable live data. And the solution was to provide an explicit field declaration where you can have both live data and mutable live data, which is accessible only within the private scope of your container. But we've been going actually back and forth with this feature, as if you provide such a mechanism in the language, you'll immediately get into questions like, what if I use my field inside a public inline functions? Should I go straight to the public accessor or my private one? Or what if I return such a field from my function? Should it be a field or should it be a getter? And for now, we've been thinking that we are going to introduce optionally named explicit backend fields to resolve those conflicts. And the feature for explicit backend fields was released as experimental in 2.0, and we are aiming to provide updates on it in Kotlin 2.2. And that's all from my side. So thank you very much for attending the talk, and thank you. So we have some time for questions.
Hey, Michail. Thanks for presentation. I'm here.
Yeah, thank you.
I have a question. Is there any tool or script that would allow to convert my existing pre-2.0 Kotlin code into the new? Like, for example, that column renderer function that you introduced, and you were kind of improving it from one slide to another.
Yes, so actually with each release, we provide automatic migration for new features, and especially with those features, it's really simple. So yes, we are going to provide automatic migration via our IntelliJ IDEA plugin and fleet.
Okay, thank you.
Hello.
Hello.
So I would like to ask about this switch thing. So what was the reason why you have to introduce the if in there instead of using the logical operations? Because that would allow also the or. So I'm wondering, like, why that was this way.
So initially, actually wanted to use end-end so that it will be very straightforward and you don't have to learn anything at all. But as we saw, we bumped into a few issues because it will become not clear when you want to switch over logical expressions, because end-end in that position, it's not actually end-end. And there will be more puzzlers with things like true and false, which is actually won't be resulted in false, because it's actually a guard, and it will be executed after the first check. So that's why we had to provide something more additional to that, and we had to use a distinguished construct for this.
Yeah, I also have a question here. Regarding the last example that you gave, when you have that hidden field and then and you expose that in a kind of a read-only version in this new construct, if you use it outside the class and it is actually the same property that you return, you could cast it and then modify it anyway. Is there any protection there automatically, or do you need to declare that explicitly?
Actually, it won't be possible to cast it because it's not a subtype. So you actually can use different types here for field and getter. And in your getter, you can have a totally different type, and your explicit cast will be resulted in the class cast exception.
Okay, thank you.
Hi, I have a question related to so Java, a lot of has probably been inspired a lot by Kotlin and been moving really fast in the past years. And I'm kind of curious, is there any any hypothetical features in Java or the JDK or the JVM that you will have on your wish list that would open up a whole new thing for Kotlin or similar?
Yeah, that's a good question. So probably the main feature in Java that has right now which is more powerful in Kotlin is their pattern matching, and this is quite complicated story as Java introduced so-called positional pattern matching, where you can have some problems with forward compatibility, but it's still very powerful. And we are slightly hesitant to add the same construction to Kotlin. But we are looking into Java and how developers are adopting this feature. And right now, we are thinking that once we figure out this story with named-based destructuring, we'll be diving into pattern matching capabilities, but without positional destructuring. And this is where we'd like to use the experience from Java.
So, hi here. I got one more question back to the when with subject and the new guard statement. So on your slide, you removed almost all of the search panel words, but there was one left that was always in green, and that was the search panel is blocked. So why couldn't you take the subject as like an implicit receiver so that this could also be used as not blocked there, instead of having the subject with a name? Thanks.
Yeah, so we've been discussing this idea, and in some prototypes we've even used like $sign to capture like this particular status variable, for example. But in our experiments show that it actually doesn't provide much value, and the code becomes really implicit and unclear, because sometimes you'll have to use explicit variables, and sometimes you don't, and it just doesn't worth it from our perspective. Yep, I see more hands.
Hello. So I have a question regarding unionized error type. So you mentioned that this feature would be only enabled for exception and error states. How do we plan to mark function that it's allowed to use this structure? Because last is not like exception or something error match function.
So the idea here, and it's crucial, that we want to provide a separate category of types, which will be called something like errors. And it will be possible to combine union types with those specific types from this category. And this category of types will have a method probably a method like throw, so it will be compatible with exceptions, and will gradually make all the exceptions errors in Kotlin.
Yeah, also a question about union types. You mentioned that union types, if in general use cases have those issues, but if you're going to implement union types for errors, then you're going to have to solve those issues anyway. So why not make it for general cases as well?
So actually, we don't have to. Actually, we have a polynomial algorithm, and that's because in this kind of unions type, you have like one main type, which is like a regular type, and a set of extras. And this allows us to have polynomial algorithm for type checker. And also because we have this main type, and we know that it will be only there, it's a single one, we can provide more operators for better ergonomics.
Thank you. And also you mentioned that there is another talk that we might want to visit to learn more about union types. Can you say that name again?
Yeah, so it's a talk by Ross Tate. He's our researcher, and we collaborate with him. And he also contributed to Kotlin, like regarding such topics as flexible types and declaration site variants. So, and right now we are working on union types for Kotlin.
Hello. A question. Sorry. A question regarding smart casting. When working in a large multi-module project, we see that smart casting across the module boundaries is not working, and also libraries which provide immutable data is still not possible to smartcast. Is there any work ongoing related to this?
So, to be honest, we don't have smartcasts across multi-models in our short-term plans. But yes, that's actually a bummer that in many cases we can't use like mutable variables. And I think that with upcoming more features around immutability, so we are going to have vars there anymore, but those will be some special vars. It will be possible to provide more smartcasts for them.
Okay, thank you.
I have one question about the structuring. Yeah, the question is, if I understood correctly, now the names of the variables will be locked to the names of the fields, right?
Right.
And what happens if we need, for example, to destructurize two equal classes, like two users or two anything?
That's a very reasonable question. So for that, we are going to provide special syntax to rename your properties. So it will be something similar to when you're passing an explicit parameter when you're invoking a function. And there will be something similar.
Thanks.
Hi, question about smart casting and data flow. Normally we only track Boolean, null values and simple types. Is there a plan to track more complex things such as a list is not empty, or add other kinds of more complex Boolean logic to the way the data flow works today?
Short answer is yes. So this is the part about effect system capabilities. So like, let's say our holy grail is to be able to write functions where like filter and then it is, for example, of type string. And we'd like to actually be able to smartcast the receiver to this type. But it's quite a long journey, but we are going to provide, yes, more and more updates there.
So next one will be by me. On explicit backing fields, we have this integrated with Kotlin X serialization. So can I specify the backing field to be serialized?
So so serialization thing is really important as we want to provide this. So that's also one of the cornerstones for these features, as we would like to make the existing tooling work with this new feature. And because it's very popular, we'd like to provide support in Kotlin X serialization and maybe Jackson, and of course reflection. So short answer, yes, it will be possible.
Thank you.
Hello, great talk. You mentioned that you will be migrating all the exceptions to this new error category. So once you do that, will you be able to use this union type inside catch clauses, essentially having a multi-catch similar to Java?
Yes, so that's actually also one of the goals of this feature is to finally enable multi-catch feature, which is one.
Great, thanks.
Yeah.
So I guess next is me. Hi, thanks for the talk. Regarding the backing fields, will it be possible in the future to define multiple setters that accept different input types, so setter overloading, like we can do in Java today?
Well, again, to be honest, we don't have this in our short-term plans. And sorry, I didn't understand your use case. Can you?
For example, if you have a string of a username and you want to be able to set the entire user and the setter then grabs.
Oh, I see. Yes. So I see. Yeah. So it's the part about update the immutable data, and yes, we are going to work on that. So we have a design in our value classes. You might have seen it. It's in our Keep repository. It's about copy vars. So, and we also have like not we, but there's a compiler plugin by Arrow, which provides like lenses, which is the same thing as in Java, where you can have like just open a Lambda and updates the necessary fields. But we also think that it's not the best way to do so, because if you want to update like something more nested in your class, it becomes very like verbose, because you have to open a few lambdas and the nesting thing goes really crazy. And also it's hard for the compiler to update only the necessary part of your class.
Thanks.
A question, perhaps it's a big one, but Project Valhalla and value objects, how do you see them come into play for Kotlin?
Oh, that's actually great. We are really waiting for Valhalla, because we have our own value classes and we are waiting to like extend them for multiple fields. So I just, like, as probably everyone, I'd like to, and I'm waiting for the release of Valhalla project. So it will be really great. And with Valhalla project, it's also one of the points why we are working on this immutability thing. And that's why we want to provide a short and convenient syntax to update your data class objects and value class objects, which will be especially important with the upcoming Valhalla. Okay, so I think that's all. I will be here for the next day. So just ask me questions directly and see you soon.